So let's take a look at this truth table. It's going to be a little bit more complicated because there's just going to be more columns. So here I have P or not Q and Q. So I'm going to have P, Q, not Q, P or not Q, and my whole shebang here, which is P or not Q and Q. And it looks like I didn't need this extra column right here, but that's okay. So let's go ahead and fill in our truth values. I have true, true, false, false, true, false, true, false. Not Q is going to be false, true, false, true. So now I have P or not Q. Remember, or is true if I have one or both of them being true. So if I look here, for this column, I have P or not Q, so true or false is true. P or not Q, true and true is true. P or not Q, false and false, that's going to be a false. And then P or not Q, that's going to give me a true. Wonderful. So now I can go ahead and figure out the truth table for everything all together. So now I'm looking at, in parentheses, P or not Q and Q. So the two columns I'm going to be looking at primarily now, I'm going to make them in green, are this one right here and this. Remember that and is only true if both compounds, so both parts on the other side of our and, have a true truth value. That's a tongue twister. So let's take a look. I have true and true, which is true, false and true, which is false, true and false, which is false, and false and true, which is false again. So therefore, I have completed our beautiful truth table. So you can check your answers. Now, what if I have three simple statements, P, Q, and R? So let's go ahead and break it down. P, Q, R. I also have not P. I have not P and Q. And I have not P and Q implies R. Now, I have three different statements. Each of them has two possible truth values. So 2 to 3 is 8. So there's 8 possible outcomes in my sample space. Okay? Just like when we were flipping 3 coins, there's 8 possible outcomes in our sample space. So I'm going to make sure I got all of my possible outcomes. And the simplest way to do this is by filling in P first. So because P has 8 possible outcomes, I know that true of them, half of them are going to be true and half of them are going to be false. That's the same for P, Q, and R. But I need to make sure I get all possible combinations. So for Q, let's go every other 2. So I've got true, true, false, false, true, false, true, false. Now for R, I'm going to switch every other one. So I've got true, false, true, false, true, false, true, false. Now we see I made a mistake right here, because it's supposed to go true, true, false, false. And if you do it in this method, you can see I've got every single possible outcomes. I've got 3 trues, 2 trues, false, true, false, true, true, false, 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 true, true, etc. And you can check those answers for yourself. This is just the most organized way to go about it. Next, I want to know what not P is. And I don't want to zoom in like that. Okay, I've got false, 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 true, 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 true for not P. Next, I'm looking at not P and Q. Remember that and is only true if both of our values are true. So I have a false and a true, which is going to be a false and a true, which is going to be a false and a false, which is also false. Same thing here. I've got a true and a true, which is true. I have another true and another true, which is true. A true and a false, which is false, and a true and a false, which is false. Now for our final answer, we're going to be looking at this column and this column because we're looking at not P and Q implies R, and this little negation symbol should have been inside. Sorry about that. So remember, implication is only true if my conclusion is, if my hypothesis is true and my conclusion is false. So here I have false implies true, which is true. False implies false, which is true. Sorry, false implies false is true. False implies true, which is true. False implies false, which is also true. Maybe we're going to have a tautology. I don't know. Friendly reminder, tautologies are when we get a true answer every time. Next I have true implies true, which is true. True implies false, which is, oh, false. Darn it, so close. False implies true, which is true. And false implies false, which is also true. So there we have the truth table with 3 variables. I say we do one more with 3 variables, right? So we get the hang of it. So let's construct the truth table for not P or Q and R. So I'm going to set this up. I've got P, Q, R. To get every possible combination with 3 variables, I want 4 trues, 4 falses, and I divide 4 in half, which is 2. 2 trues, 2 falses, 2 trues, 2 falses, and then I divide that in half again, which is 1. So I have true, false, true, false, true, false, true, false. The other columns I need are P or Q, P or Q and R, or Q and R, and then my whole statement, which is not P or Q and R. So let's look at P or Q. Remember that P or Q is true as long as one or both of my simple statements are true. So I'm looking at these 2 columns over here, and I have true and true is true, true and true is true, false and true is true, false and true is true, true and false is true, true and false is true, and then false and false gives me false. I need one or both to be true. Next, I'm looking at P or Q and R. Remember, ands are only true if our simple statements, so the stuff on the other side of the and, are both true. So I'm looking at this column here and this column here. And when I have 2 trues, that's when I get a true value. But I've got a false and a true, so that's a false, a true and a true, so true, false and true is false, true and true is true, false and true is false, false, and false. All right. So now I've got the negation. I've got not P or Q and R. Remember, negation just changes the truth value if it's true to false and false to true. So I'm just going to go ahead and switch my truth values in this column. So I've got false, true, false, true, false, true, true, true. Final answer. Okay, so here is our beautiful truth table.